let's talk about blood pressure, homeostasis. And what homeostasis means is balance. So how is it that our body is able to create balance for our blood pressure? So this is the heart, and we've got branches of the aorta coming off of it. I haven't been drawing these branches every single time, but this time I think it's quite helpful to see. We've got here the left brachial artery going out to the left arm. And we've got the left carotid artery here. And again, I'm writing left and right from the perspective of the person whose heart this is. And you've got here the right carotid artery and the right brachial artery. So this is blood going to the right arm. And we've got blood going to the right neck. One interesting thing, if you look at the right carotid, is that it bulges right here. In fact, both sides do. And they bulge right before they split. And so that bulge is actually called the carotid sinus, right here. Carotid sinus. And we call it that because a sinus is any cavity. And so this is the right carotid sinus, and this is the left carotid sinus. Another spot I'm going to talk about in this video is the aortic arch, which is right there. So these three spots, the two carotid sinuses and the aortic arch, are really, really interesting, and actually they're very important for learning about how it is that our body is able to create balance in our blood pressure. So at the top I drew kind of a blow-up version of the carotid sinus, and at the bottom is the aortic arch. And if you look closely under a microscope, you'd see nerve endings on the outer layer of the vessel. And so these nerve endings basically join up and form a nerve, and these on the carotid sinus do the same thing. And they are basically going to form two large nerves that go off, and they send information about what's happening in the blood vessel, specifically about stretch. So as blood is pulsing through this vessel right here, this carotid sinus, or as it's pulsing through the aorta even, that wall is being stretched out. And as it gets stretched out, these nerves, they're very special nerves, they're called baroreceptors. Baro meaning pressure, and they're receptors for pressure, so they're baroreceptors. These baroreceptors are feeling the effects of stretch. And what they do is they send a signal down the nerve that tells the brain how much stretch is happening. And so if this is the brain, let's say, and you have here your midbrain, these nerve endings are going to actually go here and tell the brain, communicate information about how much stretch is happening in those vessels. Now we know that the more pressure is in the vessel, the more it's going to stretch. So follow with me in a little example. So let's say we have blood pressure here, and let's say I have my blood pressure of 115/75. And in green, I'll write action potentials per minute. Action potentials per minute. So what happens is that as my blood pressure is 115/75, those nerves are feeling a certain amount of stretch, whatever that amount is. And they're going to send a signal, not just one, but they're going to send a handful. So let's say they send 10 signals. 10 signals. I'm going to draw them out here. 5, 6, let's say 7, 8, 9, and 10. 10 in 1 minute. And actually, let's just imagine that both nerves are doing this, right? So they're doing 10 per minute. Well, that's a pretty normal number, let's say. And this, over time, becomes what the brain regards as my normal set point. The brain starts to assume that if 10 action potentials are fired per minute, then that's pretty normal for me. So it regards this as my normal set point. Now, if my pressure goes up, let's say that I'm running late to an exam or something happens that really worries me and my pressure goes to 140 over 90. Now I have hypertension. And this is my new pressure. This would be much higher than normal. So my body would register this and my nerves would start firing, let's say at 30 times per minute. 30 times per minute. So if they're firing at 30 times per minute, then my body is thinking, or my brain is thinking, well, that's higher than normal. So this must be high. It regards this as high. And on the flip side, let's say that, I have, let's say I cut my arm and I lose a lot of blood and my blood pressure starts to fall. My stretching is going to happen less than before. So it's going to send less action potentials per minute, maybe only 7 per minute. And again, my midbrain is going to get 7 little green arrows per minute, 7, action potentials per minute. And it's going to think, well, that's very odd. Before it was 10 per minute. So this represents a fall in blood pressure. So now you have high blood pressure in pink and a fall in blood pressure in blue. So what exactly can the brain do? What can the brain do to help normalize or create balance? So let me write that over here. Let's write response, question mark. Response. So the body has a couple of strategies, and they're basically summed up in the autonomic nervous system. Autonomic nervous system. And there's 2 major branches of your autonomic nervous system, or 2 parts to it. Let's say parts. One is called the sympathetics. Sympathetics. Almost like sympathy. And the other is called parasympathetics. So very similar words, except the word para is in front of this one. And I want you to remember now that there's a formula, and I'm going to write that formula down here just to remind us that pressure equals flow times resistance. And additionally, I want you to remember that flow, this one right here, is going to be related to stroke volume times heart rate. So if I can do anything, if my body can do anything to raise the stroke volume or the heart rate or the resistance, then my pressure will go up. And vice versa, if I can drop the stroke volume or heart rate or resistance, then my pressure will go down. Okay, so what the sympathetics do is they have an effect on the heart and the vessel. So the heart and the blood vessels. And these blood vessels are all over the body, not just the carotid sinus or the aortic arch. I'm talking about all blood vessels. And so the sympathetics are going to, for the heart, they're going to increase the heart rate. And they're going to increase the stroke volume. And the parasympathetics do the opposite. They actually drop the heart rate and drop the stroke volume. And the way that they do that, the heart rate is controlled by how many beats you get per minute. Obviously, that's the heart rate. And the sympathetics are going to cause the heart cells that control that to work faster. And the parasympathetics will slow them down. And for the stroke volume, the sympathetics force the heart to contract harder. And then you have more volume of blood gushing out with every beat. And the parasympathetics make the heart work less forcefully. So you have less blood gushing out with every beat. And the sympathetics, finally, they actually cause vasoconstriction. Vasoconstriction. And you guessed it, the parasympathetics do the opposite. So they cause vasodilation. And vasoconstriction and vasodilation basically mean whether the artery stays open or closes down. So for the sympathetics, the arteries and arterioles primarily, mostly it's the arterioles, they start to get smaller. And as they get smaller, that increases resistance. And for the parasympathetics, they will cause the arterioles to get bigger, to dilate, and that will cause the resistance to fall. So taking a quick peek at our equation that I wrote out for you on the right, you can see that the sympathetics basically do everything that will help to increase the pressure. So if you have a pressure, again, of 140/90, then what will happen is your body will see that as a high pressure and will try to get the parasympathetics to be active. We'll activate all the parasympathetic nerves. And if your pressure is low, if it's 90/60, then the body is going to respond by getting all the sympathetics to react. You see how that works? And of course, if your pressure, let's say, is 115/75, and the baroreceptors are firing, the usual 10 times per minute, then there should be really overall no response. So here you would really get no response, because the body is thinking, well, everything is already balanced, there's nothing for it to do. So this is how the body is able to control blood pressure in a rapid way. So that's the final point I want to make, that the input here, the baroreceptors, these are nerves. And the autonomic nervous system, obviously these are nerves. So the information going in is the baroreceptors. The information going out is the autonomic nervous system. And all of this is happening rapidly. This is all very rapid. And when I say rapid, I mean on the order of kind of seconds to minutes. So within seconds to minutes, this response can happen. So this is a fantastic example of how your body can take in information really quickly and really respond quickly to help keep your blood pressure balanced.